We stand on the brink of a historic opportunity. The interstellar object 3I/Atlas, this uninvited guest from the depths of the galaxy, is hurtling through our solar system at a breathtaking speed. Now, the big question is, can we launch a space mission to chase it down and uncover its secrets up close? Join me on Astraeon. First, let's look at the main challenge. To reach 3I/Atlas from Earth, a spacecraft needs an initial velocity change of about 24 kilometers per second. This delta V, as it's called, is like slamming on the gas to escape the heavy traffic of Earth's gravity. That energy amount is roughly equal to what the Dawn spacecraft used to reach its destination. But 3I/Atlas is moving at 58 kilometers per second relative to the Sun, so any close pass, what we call a flyby, meaning flying by the object without landing, would happen at a relative speed of over 60 kilometers per second. For comparison, when the New Horizons spacecraft passed by Pluto, its speed was only 14 kilometers per second. And even that made imaging challenging. Here, imaging would be like snapping a photo of a race car zooming by, but if we succeed, we could examine its ice compositions, dust, and organic materials to understand how planets form in other star systems. 3I/Atlas will pass just about 29 million kilometers from Mars in the fall of 2025, which is much closer than its distance from Earth, about 10 times closer. From Mars, we only need a 5 kilometers per second velocity change, which requires far less energy. Current spacecraft orbiting Mars, like NASA's MAVEN studying the planet's atmosphere or Odyssey doing mapping, have leftover fuel, around 10 kilometers per second, that could divert them toward 3I/Atlas. It's like prepping an old car for an exciting road trip without needing to buy a new one. The time window for this is limited, but if we act fast, it could be a major scientific win. The real excitement peaks with the Juno spacecraft. Juno has been orbiting Jupiter since 2016, exploring the secrets of this gas giant's atmosphere. Now, it could play the hero. With a smart maneuver near Jupiter, what we call an Oberth maneuver, using the planet's gravity to boost speed like slinging a stone with a slingshot, Juno could alter its path and approach Atlas in early 2026. With its remaining fuel, it could get as close as 27 million kilometers to the object, where its cameras and instruments could examine surface compositions and any potential activities. This idea is like awakening a veteran explorer for one last grand adventure, and it could open a new chapter in cosmic discovery. There are other options on the table too. The Janus mission, 2 small spacecraft designed to study asteroids, could be redirected toward 3I/Atlas with a quick launch. Or OSIRIS-APEX, which previously brought back samples from asteroid Bennu, could now observe the object from afar with its advanced cameras. For the future, the European Space Agency is launching the Comet Interceptor mission in 2029, a fast spacecraft that waits in a stable point in space to dash toward interstellar objects or comets, with small probes for multi-angle observations. To complete this adventure, even more innovative ideas have been proposed. For instance, a rapid launch with multi-stage gravity assists, using Earth's gravity and then Jupiter's for extra acceleration, like leaping from one launch pad to another. Researchers suggest using powerful rockets like NASA's SLS or SpaceX's Starship for direct launches with heavier payloads, allowing us to bring more advanced instruments. Small CubeSats or nanosats could also be launched as companions to main missions, like little passengers on a big ship. There's even the laser sail idea, inspired by the Breakthrough Starshot project, a sail propelled by powerful lasers from Earth, no traditional fuel needed, and the concept of permanent chaser missions. A base or spacecraft at Lagrange points like L2, always ready to sprint toward any appearing interstellar object. This is broader than Comet Interceptor and could change the future of exploration. But alongside all these ideas, we can't ignore the real problems. The biggest challenge is the limited time. Atlas is zooming by at a dizzying speed, and our decision window has only a few months left. If we don't plan right now, the opportunity will slip away. On the other hand, many existing spacecraft like Juno or Mars orbiters have limited fuel. That means if we want to divert them to a new path, we need precise calculations. Any small mistake could make the mission impossible. Even if we reach the object, the relative speed in a flyby is so high, over 60 kilometers per second, that high-resolution imaging gets a bit tough. The instruments need to be ready for such conditions, or we'll end up with just a few blurry images. Now, why should we go after 3I Atlas? This object could reveal big secrets, like how vital materials such as water and carbon travel from other stars to planets and shape life. The implications are huge. Better understanding of planet formation, advances in space technology, and even inspiration for future generations. If we succeed, we can analyze its compositions and see how its kinematic age, the age calculated from its motion in the galaxy, estimated at billions of years, indicates its origin from the galaxy's older regions. These interstellar objects are likely ejected from planet-forming disks around other stars. That means they're pieces of alien worlds, hurled like messengers from one system to another. If they contain water, carbon, or complex organic molecules deep inside, then these materials can travel between stars. This is the idea of interstellar panspermia, that the raw ingredients of life, or even life's seeds, could spread across the galaxy with such objects. From another angle, studying 3I/Atlas's compositions could show that planet formation isn't limited to our Sun. If this body has features similar to solar system comets, it means the rules of planet formation might be similar across the galaxy, and if its compositions differ, it could reveal fresh secrets about the diversity of worlds. Finally, there's an interesting debate. Some say 3I/Atlas might be artificial because its unusual speed and path resemble extraterrestrial structures, like Avi Loeb's ideas imagining interstellar objects as alien probes. But most scientists say it's natural, since its compositions like ice and dust match known comets, and it shows no unnatural signals. This disagreement amps up the excitement because with a close exploration, we could find the truth. If the opportunity slips away, at least we'll observe it from Earth with telescopes like Gemini North, examining activities like carbon material releases, and gather useful information from it. Thanks for your attention.